One of the people I meet over travels a lot is Dieter Sarrazyn, because he's one of the SANS veterans, especially for the ICS community. So if you haven't heard a talk of him, under what rock have you been hiding over the past couple of years? So Dieter, as you all know, probably is a freelance ICS security consultant, has a wide background in various industry verticals and different approaches to ICS security assessments. He also provides training and awareness sessions to young graduates and newcomers to the ICS field. So that is a very, very highly regarded, some very highly regarded activities you're doing there, Dieter, getting more people into the field and actually guiding them while they're trying to figure out what is what in ICS security. Today, Dieter will talk to us about cybersecurity, FATSAT testing and its pitfalls and wins. And here's why this is important to me. Those of you that ever attended the ICS 515 class, you know that we have that one slide in there that says, yeah, when should security be considered in ICS environment? Yeah, during design phase or FATSAT testing. And that is all we tell you. And then usually just to keep, because I mean, there's many slides and a lot of topics to cover. Usually the easy way out for a SANS instructor when you start the discussion around that is, yeah, let's talk about that during the coffee break, or we're an incident response class. We're not a planning, design, and assessment class. So now I'm looking at Dieter to actually give the background on that one slide in the 515 class, like how do you do this actually for real? So Dieter, welcome. The floor is yours. Tell us all about FATSAT testing, pitfalls, and wins, please.
Thank you for the introduction, Kai. So, is this working, the slide deck? Can I move the screen? Yes, no, yes. Okay, so cybersecurity FATSAT testing, the pitfalls and wins. A little bit first about me. So as Kai said, I'm already a long time busy within cybersecurity, so active in cybersecurity since I think 1998, something like that, after I graduated. But then I moved to the ICS cybersecurity range within, I think, 2008, when I did the first penetration test on one of the largest energy suppliers in Belgium. But mainly what I do is challenging ICS vendor solutions and performing cybersecurity FATSAT testing in ICS. Over the years, doing FATSAT testing, I have gathered a lot of pitfalls and luckily also a lot of wins. So the do's and don'ts for cybersecurity FATSAT testing. As I mentioned at the SANS IPAC ICS Summit in 2020, you should not trust your supplier integrator, but actually you should trust your supplier integrator, but you have to verify it. You have to verify what they have implemented. You have to verify security of their solutions and things like that, because security testing is no longer an optional thing. As it is also mentioned within ICS 515, the security FATSAT testing. So you can imagine that you think it might be mandatory for every project that suppliers or integrators are doing, but actually that is not always true. So FATSAT testing is factory acceptance testing, site acceptance testing. So first of all, verification at the vendor side, which is a little bit difficult now in today's days. And site acceptance testing is verification at the deployment site. Most of the time, actually, when they talk about FATSAT testing, they mention functional FATSAT testing or operational FATSAT testing. So only looking at what the system is designed to be doing. Is that correct? Is that working? Is it all? Are the numbers correct? But often cybersecurity FATSAT testing is forgotten. It should be a pitfall. Oh, it doesn't work. That's weird. I don't know, Tom, if you could look at slides, because there should be an animation going here. So there should be a pitfall here because cybersecurity FAT is not always included within projects. So I hope for the rest of the slides my animation will work. Let's see. So cybersecurity FATSAT is actually cybersecurity validation of new and upgraded systems and solutions. but also compliance to requirements and identification of security issues. Because if you set requirements, I hope you do, if you set requirements, you have to verify the compliance to those security requirements you have set. But also at the same time, you have to identify every single security issue that you can imagine within the setup. Why do we do well, there's animation. Why do we do the verifications of cybersecurity? Of course, verification of compliance, but also at the same time during FATSAT testing, you create awareness. You might be surprised that this is the case, but you do create awareness amongst vendors, operators, and INC. I still remember the day I was doing my first FATSAT testing back in 2009. The vendor I was talking to didn't hear or didn't know a thing about cybersecurity. That was all brand new to them. And it was also the S era, so the StuxNet era. I'm no longer the first, so I can mention it. So we had to create some awareness. We had to create some buy-in with that vendors and operators to get them create better and more secure solutions. Another important thing in FATSAT testing is that you have to create, or you have to have the cybersecurity issues. All the things that you discover should be solved. I said should, it's not always the case. More at least they should be known before you go into commissioning phases. And as you will go along FATSAT testing, and as you will go along cybersecurity projects within the ICS environments, you will see, you will know that the security of your environment will gradually increase. Why only gradually? Because I think you can agree with me that you cannot do just any cybersecurity testing on existing environments due to legacy reasons, due to unknown things that are out there and things like that. So by doing cybersecurity FATSAT testing, by making sure that the things you are bringing into the environment are secure, you will increase steadily on your security of your overall environment. So there's actually the first wins are here. So no more unsecured solutions will be deployed, but unsecured, yeah, that's not always 100% the case. And the second win is you improve security of your environment while going along upgrades and new installations. When would you do cybersecurity FATSAT testing? Well, in my view, you should do it for every single new system. You should do it for every new or upgraded system, and during FATSAT testing cycles, during project FATSAT testing cycles. So if you go back to the slide, when there's functional FAT and operational FAT, or sometimes also software FAT, it is often just not included within the project lifecycle, cybersecurity FATSAT testing. It is almost never included within quality assurance testing, and it should be, because cybersecurity should be looked at a way of quality of the provided solution. When would you do FATSAT testing? Well, this is a big debate. I can agree that some people might not agree with my point of view of this, but at least the pitfall number 2 that I can mention here is that you fail to include it in the planning. You fail to make sure that security testing is included. So if you look at a very simple project lifecycle flow, so procurement, engineering, construction, commissioning, and operation, most of the times the functional FAT, operational FAT is doing construction, so at the vendor site. And most of the times the SAT testing is done at the commissioning phase, so at the customer premises. But actually, if you look at the security part of it at the bottom, you will see that I put security requirements and risk assessments all the way during procurement phases already. Because actually, this is where it all begins. You set your requirements, you set your security requirements. And of course, if you don't have any security requirements, you can't meet those. A good way in starting the requirements, or a good resource in starting the requirements, is the IEC 62443-2-4 standard. And you also have to keep in mind that the security testing within the procurement phase is actually a paper verification of what the vendor promises to be doing on security elements. So he might say, yeah, we will do patching. Yeah, we will do patch management doing, for example, for Windows systems, a vService environment. We will have antivirus installed. We will do hardening and all the kind of things that he promises. But this is, and this phase, it's only a paper verification. It's only a check. Yeah, okay, it's done. It will be done. Good, perfect. Another element that you should do during procurement is start doing risk assessments on the provided solution. So you start doing risk assessment by determining criticality of the installations that will be brought in. Is it critical for the business processes? Is it critical for the whole installation or whatever? What's the criticality? So the criticality determination is a very important element here, because that might determine the further FATSAT testing process. Another important element to keep in mind here during procurement, with the security requirements, you have the IEC 62443-2-4 if you use it. If you have your own set of requirements, that's fine too. But based on what is promised by the vendor or the integrator, you should adapt your testing protocols. So later on in slides, we will see that you have to have your default SATFAT testing protocols. And in this phase, during procurement, during verification of the security requirements, you can adapt or modify that test protocol to make sure that you cover everything that's in there. During construction, what can you do there? Well, the most difficult decision here is to take is when actually within the construction phase, within the FAT phase, will you do security testing? So there's debate, do you do it before or during or after functional FAT? In my opinion, there's a win here if you do security FAT testing during a functional FAT test. Why? I'll tell you why. Is that when the operators or the engineers are actually doing the functional FAT testing, they are really working with the system. And at the same time you do security FAT testing, they will see the behavior of their new system towards security testing. To give you an example of a security FAT testing I did back at Siemens on, I think it was T3000 DCS environment. We were doing security testing and they were fully busy with doing the functional testing. And suddenly one of the engineers yelled out, "Hey, stop, this is not working anymore. What are you doing?" I know, just doing port scans. Oh, we lost that yada yada PLC. So, oh, okay. That's something good to keep in mind, because of course, during the SAT, you should not retest that particular PLC anymore because it's already in a almost productional environment. But it's very important to know for the overall availability state of that system, because if that PLC fails by just doing a port scan, well, that's a red flag actually. You also see there in the middle the actual testing, review, and changes phases. So you have this is actually the workflow within the cybersecurity FAT testing itself. You do the actual testing, then of course you create a list of issues you have identified. You review that list with the cybersecurity the provider, the SCADA vendor, and then you have a list of changes that the vendor should be doing or should be motivating why they cannot be done. It's more than likely that you have multiple security FAT test cycles during construction phase. For a particular project I did on a turbine DCS system, I think I did 3 or 4 security FAT tests at the vendor premises before it was found to be acceptable to be going into the SAT phases. The SAT is actually a little bit similar. With that difference, if you look at the actual process within the SAT testing, excuse me, you have the actual testing, review, changes, and then again you have the final phase added is acceptance. Because as I mentioned during the FAT, sometimes you have changes, proposed changes that cannot be done because of software legacy reasons, because of the software versions that the vendor is using, because of the type of PLC that is used, because of the type of environment that is used, and things like that. So at that time, you should go into acceptance phase for that particular part. because you just have to know. We know there's a security issue, but you have to know it. So pitfall number 3 I mentioned here is that you just verify issues from the FAT. So if I go back to the slide with the FAT, this one, you have a list of issues. And if you only verify those issues during the FAT, you might miss things or new things. The reason why is that it's often the case that newer environments are completely rebuilt from scratch between FAT and SAT testing phases. So if you only verify issues that you identified during FAT, you might miss things that have been errors that have been made during the rebuild phase. A fourth pitfall I can mention here is that the vendor is not providing enough motivation for the ASIS, for the why things are as they should or as they are within the environment. To give you an example on this, I'm still busy doing a SAT. Actually, it's the 3rd SAT already, security SAT I'm doing for that particular project. And the vendor is still not providing enough motivations for my customer then to be able to accept that state of the environment. So that's a bit of a problem. There's also a lot of stress put down on those motivations in this case, because as you know, projects have to be delivered on time. There's a lot of deadlines and things, even in COVID times, deadlines keep on being there. In the last phase, the operation phase, there's a residual risk determination phase, because as you have seen during the previous slides, you might have a set of issues. Those issues might be solved or might not be solved. There's motivations why particular issues cannot be solved. So now in the operation phase after commissioning, you should determine the residual risk to make sure that you cover or that you catch every remaining thing that you identified in the previous tests. The determination of the residual risk is to find out what can be done within the current environment where the newer system will be brought into, what can be done in that environment to make sure that that risk, identified risk, cannot be exploited or cannot be causing harm to the rest of the installation. So there's decisions to be made on the risk. So either you accept the risk that is there, if the risk is really negligible, you can just accept it, or you should mitigate it, or you should deter it, or you should transfer it. So making sure that you have certain decent insurance. But insurance within ICS environments based on cybersecurity, I didn't see that often yet. A big win here is that you include operations and INC teams, because they know the environment best. They know best what the residual risks could mean to the rest of the environment. Now, what to test and verify? This is a list. This is not limitative, so a lot more can be tested. But to give you a start, on the network part, you should check for open ports, network vulnerabilities, if there's traffic encryption between services or not. What about the firewalls? Are they configured properly? What are the rules of the firewalls? Is there network authentication or not? How easy is it to bypass the network authentication? On a system, you check system vulnerabilities, configuration issues, the physical security of the system. I'll tell you more about that later on. The overall physical security, agree in FAT, you cannot check the overall physical environmental security, but this is really an important step within cybersecurity SAT testing. So you should look at the peripheral ports and devices, but also the environment. So the rack, is it closed with a non-default key? Is a room okay? Is it batch protected? Is there HVAC in the room? Is there camera detection in the room, and so on? And the overall site location, is that properly protected as well? So on the application sides, a lot of times it is forgotten that there's more and more web applications within ICS environments. So not everybody looks at those web applications. And of course, also operator jail configurations checks that I talked about in the earlier slide or earlier presentations. So the Pitfall 5 is not covering everything during cybersecurity FATSAT. So that's why I mentioned that based on the requirements and the promises of the vendor, you should adapt your default testing strategy. Pitfall number 6 is that there's no baseline to verify against, no hardening baseline to verify against. Then you just take the common baselines in cybersecurity, but that's not always enough. And a big win here is that you identify other environmental security issues which could impact the other installations on the sites. On the following slides, I give you some more technical information on how to do testing and verification. So open ports, you should make sure that you include both TCP and UDP on all ports. On vulnerability scanning, you should make sure that you scan all ports, you perform SSL verification on all ports. And if depending on the vulnerability scan you use, you should make sure that you include SCADA plugins. When I do testing and FATSAT testings, I do at least 3 scans unauthenticated to see what's the situation from a just somebody who plugs in point of view, authenticated to make sure I cover everything on the system itself, and unauthenticated with safe checks disabled. Do mind that's only within cybersecurity FAT testing that I do those disabling of the safe checks to make sure that you cover denial of service scenarios to the environment. And most of all, it's important that you verify the output of the vulnerability scanning tools that you use, because sometimes authentication fails or other things fails and things like that. To make sure you cover the traffic encryption point of view, you can, if it's a managed switch, you can use span ports or you can use EtherCAP or BetterCAP to make sure that you verify traffic encryption. Of course, most SCADA protocols like Modbus and stuff do not have yet traffic encryption, but I'm talking more about Secure Shell, for example, is used or not instead of Telnet. Is there SQL encryption and things like that? So it's important to look at. On systems, this is a list that I put down of things that you can verify or should verify. Notice that there's 3 dots at the bottom. That is not limitative. At least verify operating system version, patching, firewalling, interface settings, remote administration if it's used, and things like that. It's important that you are really thorough in checking the systems, what you can imagine. I also mentioned operator jail breakout possibilities. I talked about this in an earlier presentation, but this is making sure that if there's operator jails, so if the operators are limited in what they can do on the systems, make sure that you verify if you can break out of those operator jails. Sometimes it's very easy, sometimes it's a little bit more hard. In the SAT exercise I was talking about earlier on, this the 3rd security SAT test I was doing for that environment. I only found 1 operator jail breakout anymore using the browser that I use for accessing their services. But the first FAT I did on that particular environment, well, there were a lot of more operator jail breakouts. So gradually on, they are improving their security posture. On industrial devices, you have firmware versions, protocols, default username passwords. That's a easy way in sometimes, most of the times. Enable ports and things like that. So again, it's not limitative. And the standard testing checklist I mentioned earlier on, that's something you should have when you start doing cybersecurity FATSAT testing, but be ready to adopt it or change it when or based on the security requirements. Another pitfall I can mention here is that you treat security FATSAT testing as only being a penetration test or only being compliance testing. I think as if I'm guiding you through those slides, you can imagine that FATSAT testing is way more than just a penetration test or just a compliance test. It's actually a combination of different elements of both combined into one big exercise. How can you do FATSAT testing? Well, you connect to every single network that you can find on the installation you have a test. You connect to every single network interface of all the systems to verify if these are disabled or not, if they have to be disabled. Connect to every single device interface. So the console interfaces, USB interfaces, other peripherals, so serial interfaces as well, and things like that. And you should include every possible viewpoint from that environment. So local networks, adjacent networks, or remote access possibilities. One of the pitfalls I mentioned here is that you do not consider differences between FAT and SAT. So it's often the case that in the FAT environment, there's a certain remote access for the vendor to be to have easy view on the FAT environment, but the remote access in SAT is through the organization's environment or through DSL or whatever. And if that's forgotten, that might be an easy way in for attackers, of course. A win here is, I found that a win at least, is determining how easy it is to reach a system or environment if you take all different viewpoints into account. I mentioned you should connect or try to connect or use every single device interface. There's a few examples I show here on the slide. So the network interface, first of all, verify if these are disabled, fixed IP, or not configured. I found it often the case that unused interfaces are just left active, but they're not used. So if you connect an attacker laptop with DHCP server on it, they will get a valid IP address that can use to potentially attack that system, for example. But on USB interfaces, most of the times now today is that storage drivers or for your USB sticks are disabled, but all other drivers are left untouched, which means that you can connect USB to Ethernet dongles, USB to serial dongles, and things like that. When you, for example, connect USB to Ethernet dongle, if you have a hardened system shown on the left, you use an USB to Ethernet on a free USB port, you will get a new interface with everything enabled by default. Using DHCP, again, if you connect your system with a DHCP server on it, you might have access to that particular system. Even it's so that if there's SCADA protocols configured on the system, they will be enabled on the new interface as well. On the physical part, so I mentioned that physical environmental part is also really important to do in the cybersecurity FATSAT testing. This left one, there was a nice rack. It was locked with a non-default key, luckily, but I forgot there was an opening at the bottom, at the top, that you can unscrew parts of it and put your hand in it and touch the console interface, for example, and connect the cable, and voila, game over. Here's just an Ethernet connector dongle, and this is a free at the right in free Ethernet port that you can connect to. So make sure that you cover everything for the particular environment you are testing. Then, of course, we entered the remote FATSAT era in the last year. Remote FATSAT can be done because of pandemic reasons, of course, but also due to economic reasons. I know there's debate ongoing on how you can do it. I know there's another presentation coming up talking about this particular issue. But doing a remote FATSAT testing exercises can be dedicated or using a dedicated testing device that's phoned home to the tester's system or environment. Or you could use a secure KVM access using ILO or iDRAC or RDP or whatever. Sometimes it's using a video chat session that they walk around with a camera and make sure that they show you everything that's out there. But do be aware that not all FATSAT testing within your default testing protocol might be possible. So in my opinion, physical FATSAT testing is still the best. A way of working around that limitation is that you do FATSAT testing just before the systems, just before the SAT and when the systems are on site. The problem with that is that you might, or that the vendor might not be able to do any changes anymore to the environment. And there's a big pitfall here is that you increase unwanted connectivity for high secure environments. Depending on what environment you need to test, you need to verify, you increase having another connection into that environment that should not be existing. And of course, a big win is saving on time and project costs. So it's a debate on debate between security and economic reasons and feasibility of what you can do. Or you can just simply combine FATSAT into one single exercise and hope that the vendor can also make changes, make the necessary changes to the environment. And of course, the security FATSAT reporting is one of the biggest thing, the reporting phase. It's the most annoying thing for testers, I know. I feel the same way too, but it has to be done. So the pitfalls here and the wins here. So the pitfall is not including all performance tests and results. What I mean with this is that you have to write every single thing down that you have tested, every single result down that you have tested. This is really important if you are dealing with some regulating organization. That's more the case within heavily regulated sectors, but that's really important. Another pitfall is that the project team is not sharing results with the vendor. Happens a lot. That the project team at the customer side has the results, but the vendor has never received the results of the FAT testing, for example. So you do the SAT testing, you have the same issues all over again. So which means that the vendor hasn't done anything. So you start slapping on the vendor's head, but actually the project team didn't share the results, so the vendor couldn't do anything he didn't know. But that's also not completely the case. He should know that what he should be doing. The wins here is that if you use the report iterations showing the progress, so the report of the FAT, you use it again to report the SAT things, and you show the progress. So that's a big win for your customer as well, and for the management of the customer. And another win is that security FATSAT testing can be reproduced, because it's not always you who will be doing the same testing all over again. So that's also something to keep in mind when doing cybersecurity FATSAT testing. Other aspects, standardize your approach. Be ready to educate vendors, operations, and INC, and embed cybersecurity FATSAT testing within project quality assurance processes. The biggest win is that security testing should be embedded within every single project lifecycle or project management lifecycle. Planning of security testing is no longer optional in my point of view. And last but not least is build and create a cybersecurity testing strategy. So make sure that your existing environments are regularly tested while keeping safety in mind, of course, and operations. Do cybersecurity testing on every single new and upgraded equipment and environment, and have or potentially have your own testing equipment team or advisory emulation ready. And I think this was the last slide, but always make sure you include the logical, human, and physical elements. So logical, of course, is the systems and network vulnerabilities. Human aspects comes more into play when doing the SAT testing, and the physical parts comes into play during FATSAT testing as well. Play the what if game. That's really funny when doing security testing. Thank you for your time.
Thank you very much, Dieter, for finally clearing that up. FATSAT testing. There are quite a few questions, which I think is good news. So people actually do care about testing, which is, to me, I mean,
perfect.
That is really news. I mean, I love the physical side channel attack photo you had in there. Like, the door is locked, but you can go through the air vent / cable access of that rack.
Yes, always
I
works.
might or might not have done that a few times in my career.
Even with that particular rack, I don't know if you can quickly go back to that slide. There's one element I can tell more about that one, is that there's a gaze front of that rack. I don't know if it's going quickly back. Yeah, whatever. There's a gaze front of that rack, and before we went in with our hands into the rack from the top, we just put a cable through that hole and used some tweezers through that gaze rack to put in the cable into the port with this slide. Yes, so there's a gaze thing here. So we used some tweezers to put it in without our hands. That was fun to do, actually.
Yeah. Oh boy, we should swap so many stories over beers. Let's get to the questions, though. And I mean, we definitely need a beer, especially Duvel once we go back to Brussels.
Yes.
So question
certainly.
number one, do you have tips when discussing security from a supplier or integrator if security knowledge is very low on the contracting party? like they want security, like especially like spray on security, like if you with my air can. So what's your take on that if there are no clear requirements?
If there are no clear requirements, so if the requirements have not been created or not been set, I just do regular security testing and see what comes out of the test phase and start discussing those issues that are coming out of that with the organization and the vendors as well. Because I mentioned it's also part of education that you're doing during security FATSAT testing. So that's as part of the education phase that I'm talking about. So you take the issues, you explain to the both vendor and the customer organization you are testing for, what are the potential risks and what could that mean for the installation you are testing, but also what could that mean for the overall installation.
Thanks. And maybe as a follow-up to that, so would you also preclude that type of testing with at least a limited briefing of the parties involved, so everybody has a clear understanding of the terms and what security means?
Yes, exactly. So that was the review cycles within the FAT and SAT testing that is really important. So the review cycles are really important to make sure that everybody understands properly what's at stake.
So there are quite a few more questions, and since we're a little bit up on time, I'll ask the team to forward them to the hallway. But let me end with one that goes pretty much to like monitoring solutions and tools. So under what test verify bracket would you put OT monitoring solutions like Nozomi, Clarity, which provide data on vulnerabilities? So this is about like vulnerability scanning or passive vulnerability sniffing in these environments. So how would you place that in a test of this type?
First of all, you have to make sure that you know what you want to monitor. That's one part. And then you have to test what the monitoring solutions is catching. When you do, for example, port scanning, simple port scanning, when you do, for example, vulnerability scanning, is that monitoring tool catching that already or not? What's the reaction? What's the response configured within that monitoring tool? But then I would take it a step further, is taking actually samples, not connected to the full environment, to the ICS environment, but I would take that monitoring tool apart and use real samples of a malware, launch it through an isolated network and see what happens with that detection capability. What does it do with it? What can it not do? I think it's really important question, because I had the case where I was together with a customer evaluating some monitoring solutions, and only one of those solutions detected WannaCry, for example. That was shocking, but was the case.
These things tend to happen. With that, I mean, my recommendation would also be, I mean, number one, and this comes from a guy that works for a dirty vendor, always, as Dieter says, test all the tools from all the vendors, and then includes mine with exactly like Dieter said, real world data, not just the PCAPs you get from the vendors for show and evaluation. And also take into account what we learned in the previous talk from Salima. The FAT test might be, so the FAT test might be the one point where you can actually use your site as a range. So having a red team go in exactly that point in time. So as you mentioned, during, so not opening the discussion here. So my hate word in the automotive industry was non-functional requirements. Security is a functional requirement because it messes with your process. So have a red team go in during the FAT, have them have a go at how to disrupt your processes so you see what's actually happening when the process goes sideways. Remember what Mike Hoffman talked about yesterday, like the most important aspects of a plant usually being those secondary systems that keep the plant up and running, process air, electricity, water, right? Like what Dieter showed in the images in your fantastic slide deck. These are the things that take the plant down, like not messing with the robots. That is Hollywood.
Exactly.
That was me ranting, so apologies for that.
No problem at all.
Thank you so much.
So one thing I would like to mention though is that security FAT testing is almost the single time in a project that you can go all the way So I call it full Monty testing, so you can open up every single register you have.
100%. So I hope there's a lot more follow-on discussion in your hallway. Guys, please
I will have a look.
all the remaining questions of Dieter in the hallway. Thank you again, Dieter.